Problem number 3. T is 2 pi over 3. We want the reference angle, so we put 2 pi over 3 in standard form. If you want to go all the way to the negative x-axis, that'll be pi. So you lack pi over 3. That's the reference angle. What point is that? On the unit circle, 2 pi over 3 is negative 1/2 square root of 3 over 2. Remember, in the second quadrant, x is negative, y is positive. Using the x and y value, x is always the cosine, y is the sine. So the cosine must be negative 1/2. The sine is square root of 3 over 2. You know the cosecant is 1 over the sine. The secant is 1 over the cosine. And finally you do the tangent. It's sine over cosine. And cotangent is the reciprocal of the tangent. You have to rationalize the denominator. So you have negative square root of 3 over 3. Do the same thing with negative 11 pi over 4. You need to start at the x-axis and go clockwise. Go around 2 pi and then 3/4 more. So that'll put you in the third quadrant, and your reference angle is pi over 4. On the unit circle, that puts you at the point negative square root of 2 over 2, negative square root of 2 over 2. Then you want to do the sine, cosine, tangent, cosecant, secant, and cotangent. Problem number 9, you want to use your calculator. You cannot find the exact value of the sine of 1.1. It doesn't say degrees, so you're in radians. Make sure your calculator is set to the radian mode. That gives you your answer. Make sure you round it to 5 decimal places. Problem 13, you can find the exact value of 5 pi over 2. It is starting at 0. You go around 2 pi. Then you need 1 more half a pi. That puts you at the positive y-axis at the point 0, 1 on the unit circle. So you want to find the tangent. It's the sine over the cosine, 1 over 0. It's undefined. And find the cotangent. 5 pi over 2 is 0 over 1, which is 0. Problem number 17. We want to rewrite tangent over cosine in terms of sine and just sine. So start having, so tangent over cosine. Tangent is sine over cosine. You're dividing by cosine. That's the same thing as multiplying by 1 over cosine. So that gives us sine of t over cosine squared. We need to rewrite cosine in terms of sine. We know that cosine squared plus sine squared equals 1. So if you subtract sine squared from both sides, you get that cosine squared is 1 minus sine squared. So we can replace cosine squared with 1 minus sine squared, and then everything is in terms of sines. Problem 21, it tells us that the sine is 5/13, the cosine is negative 12/13. We can come up with all the other trigonometric values, because remember the tangent is sine over cosine. The cotangent is the reciprocal of that. Secant is 1 over cosine, and cosecant is 1 over sine. Problem 25, the tangent is positive 1/4. We know we're in the third quadrant. I like to draw a triangle for that. We have tangent is opposite over adjacent, so positive 1/4 will have to be negative 1 for the opposite and negative 4 for the adjacent, because we're in the third quadrant. Solve for the hypotenuse using the Pythagorean theorem. We get the square root of 17. The secant is 1 over the cosine. The cosine is the adjacent over the hypotenuse. So the secant would be the hypotenuse over the adjacent. The cotangent is just 1 over the tangent, so it's 4. We want to combine those two values. Common denominator is 4. Multiply 4 by 4 over 4. That gives us 16 over 4, and we just change the order in which we wrote it. So it's 16 minus the square root of 17 over 4. Problem 29, we have 10 cosine 1/2 x. We want to find the amplitude. It's whatever number is out front, so that 10 is the amplitude. The period for cosine and sine, for that matter, is 2 pi over whatever this b value is. the number that's multiplied times x. So 2 pi over 1/2 is 4 pi. There is no phase shift because there's no number in the parentheses with the x. So we have to draw it. You can use your calculator to verify that that's the drawing. Y equals 3 sine of 2 parentheses x minus 1. Our amplitude, once again, is the number that's out front. That's 3. Our period is 2 pi over whatever this number multiplied times x is. 2 pi over 2 is pi. Our phase shift is to the right because it's negative 1. So you can use your calculator to verify that graph. And moving on to problem 37, we have a drawing that we want to figure out what the equation is. You can see that the amplitude is 5, so we want to put a 5 here. It starts off at 0 and then goes up to 5, so that indicates it's a sine drawing. The period is pi over 2. We know that the period is 2 pi over b, so b has to be 4. There is no phase shift, so that gives us 5 sine 4x. Problem 41, we want to find the period and sketch the graph. 3 tangent x. Notice that there's a vertical stretch of 3 here. That just means it goes up 3 times faster than it normally does. It's less curvy in here. And the period of a tangent function is pi. There's no number here in front of the x, so there's no change in the period. So the period is pi as normally expected. Notice that the drawing has the asymptotes, the vertical asymptotes. Make sure you draw those in. Problem 45, we have cosecant. We look at 4 here. That tells us the amplitude of the sine function that's inside of the cosecant function. The period is 2 pi over this b value, which is 2, so that gives us a period of pi. And our phase shift is left pi over 2. And you can use your calculator to verify that. So that's all of Chapter 5. We'll move on to Chapter 6.